Yes, sir.
Okay. So in the previous class, we were discussing the various types of layouts of FMS. So one by one, we are having here. We had a class on the various types of FMS. Now we have different types of FMS layouts. How the production is being carried out whenever you have installed a flexible manufacturing system in your industry. So there are around five types of FMS layouts that are being basically used in industry. First one is the progressive or the line type. Second is loop type. Third is ladder type. Fourth one is open field FMS layout, and last is the robotic center FMS layout. The first figure is of the line layout. You can see here the material is the raw material is entering from the left hand side of the line, and these are the workstations where the material has to get the operations performed on it, and this is the point where the material is being exiting out or leaving out after all the operations have been carried out on the specimen. So let us see, there are four number of workstations in this line. So here the material is entering from one end of the, you can see workpiece is entering from one end and it is leaving to the other end of the line. So this is called line layout here. So in this way the material is being processed. So this is what is the drawback of this line type FMS layout. You can see if any of the machines will break down or any of the machine is encountering with some error, so the whole line will stop. So there will be a buffer stop or the inventory has been created. Let us see the third workstation has some breakdown, and at that point there is a buffer stop or there is the inventory that will be generated at the workstation 2. So this type of FMS layout is generally preferred whenever there is a need of a mass production, and to avoid the line breakdown or the machine breakdown, we can provide multiple machines at every location, so that if one machine breaks down, then we can have install the second machine at the same workstations of the same type, so that there should not be any idleness in between the flow of the fluid from one end to the other end. Second figure is representing the loop type of SMS layout. You can see there the material is entering from this end as well as it is leaving to the same end. So you can see this is in the case of the loop or it is rotating. So here you can see the material is being flowing in these directions, and it is uh, all the operations have been carried out on this specimen. You can see there are six number of workstations, three on the left hand side and three on the right hand side of the loop. And you can also move the workpiece from one machine to other machines through this loop, and this loop or the parts are being transferred using the rotating conveyor from one station to the other workstations. So in this direction, you can see the period is entering from the same point and it is leaving at the same point. So you have to install the inspection machines or the vision instructions or the other inspection techniques at the common end also. Next is the, you can see this is the ladder type FMS layout. So in this, the material is flowing in the form of the ladders. That is, if the machines are being placed on the like from the ground floor to the upper floor, the material is being flowing from the lower level to the upper level, but the loading and unloading is being done at the common point. So you can see these are the workstations, and the material can flow anywhere from in between as per the arrangement of the conveyors. Next is the open field FMS layout. You can see this, what is the advantage of open field FMS layout as compared to the previous, that is ladder line and the loop layout. You can see this open field FMS layout means these workstations or the arrangement of machines can be done as per the requirement of the operations that are being stressed onto the specimen. So here you can see from this point the field is entering into the line, and here we are having some input resources which are, that is, we are getting some bricks and pixels here, and the period is being flowing in the particular direction from as per the direction of the conveyor. So it can be processed in on all the machines or it can be processed from, let us say, we need only three types of operations to be processed on a single specimen. Then it can be moved from first circuit to fifth machines or can operations like second, third, or fourth operation can be performed on the single specimen. So we can also choose the number of operations or we can arrange the direction of conveyor as per the operations that are being required to be processed on the specimen. So open field has an advantage as that from the ladder line as well as to the loop layout. Because in the line layout, there is a single flow of direction of material. In the loop, there is a rotational flow, and the conveyor is receiving the material from one workstation and transporting that material or the workpiece to the other workstations. Whereas in the case of the ladder type FMS layout, the direction of load flow is always in the vertical direction or in the from the upward to the downward directions. Whereas in the case of the open type FMS layout, we have the advantage of arranging the machines as per the requirement of the operations to be performed on the workpieces. Next is the rover type centered FMS layout. In this, you can see all the work material handling or the transporting material from one workstation to the other workstations and controlling their storage and material is all being done with the help of the robotic centered arms. The robotic centered arms are basically making the system more flexible and also removing the human assistance because there may be some error in the uh, while transporting the user from one point to another point from one workstation to other workstation. So these robots are helping to transport the unit from one end to other end, and they are being equipped with the grippers or you can say C jars through which they can easily uh, transport the rotation or parts also. You can see in the figure also. This is a robot which is receiving the material from the first workstations and then after the rotation it is being transporting the material or feeding the material to the second machine. And this is the line of the parts on which the rotation has been performed. The robot is getting the parts on this line and transporting the part of feeding the part to the first workstation and after the workstation has been performed, it is fetching the specimen on the first machine and then feeding that particular specimen to the second machines. And again, whenever all the operations have been performed, it is again robotic arm again putting that process part into this part control line so that it can be transferred to the storage retrieval department or the other next shop floor so that other operations can be performed or it should be stored or packed at the other department. Next is the computer control in FMS. So what is the advantage of computer control in the FMS? We can see everything can be controlled with the assistance of the computers. Nowadays in the workshops, sorry, so you can see all the workstations, that is production control, packaging, storage and retrieving, quality checking, inspecting the specimen, monitoring the workpiece from transporting material from one end to other end, controlling the cutting parameters at the machine area or the cutting area, controlling the position of the tool, controlling the position of the specimen, controlling and reporting all the diagnostics or the feedback to the back to the R&D department. So computer is basically, or you can say, is a all the industry nowadays. In the case of the FMS or automotive industry, is completely dependent on the computer system because we are deleting the human assistance and we are moving the errors from the system and all the operations which can be uh, carried out on the workplace as soon as the workplace is entering or the material is entering into the industry and as soon as it is leaving after packing from the industry. That is all the process as soon as the raw material is entering into the system and the finished product leaving the industry for the delivery to the customer. So all these are being assisted by the computer system. So computer control is how it is happening. So there is a basically all in all industries we have the ERP system, that is enterprise resource planning. to which you can access all the data at anywhere at any point. Like in the case of the ATM machines, you can withdraw money from any part of the country. But as soon as you withdraw the money from your bank account or from the ATM at any location of the country, you will suddenly get them text message from the bank or itself that this much is amount is being withdrawn and this much is amount that is to be left in the left as balance in your account. So this all systems is based on the ERP system. Similar is the way if you are trying to book a railway ticket or air ticket or any other ticket which is being available online, you can see that this number of tickets have been available, this number of tickets have been booked, already booked, and these number of seats are available to you can book. Similarly, this system is being based on the ERP system. That is, as soon as you are withdrawing something, it is being deleted from the data, and as soon as you are submitting something, like if you are depositing some money in your bank account, you are instantly getting the message that this much is the balance in your account. So similarly, if you are going to a store to buy something, like we have Reliance stores, we have Easy stores, we have more stores, we have number of malls in the country. That as soon as you are purchasing something, it is being minus, it is being subtracted from the whole number of products that are present in the store. Let us say you are buying a soap from the industry. So let us say soap from the store. Let us say if a particular store is having 50 types of that same company uh, product or same company soaps. So as soon as you have bought one soap from that store, the system automatically subtracted one number of soap from the system and it is showing in inventory that, and the supervisor or the agent who is delivering or who is making the doing the billing at the counter, he automatically knows that 49 number of soaps are being available in our store just now. So this is basically being based on being assisted by the computer control system. Similarly, in the industry also, as soon as the any kind of engineer, any kind of supervisor, or any kind of quality engineer or production engineer can check at any point from the system that this kind of product is at which stage, like is this at the quality stage, is this at the production stage, or is this at the packaging stage. He or she can only check from the computer system that everything data is being entered in the ERP systems. So that is why we have advantage of the computer control systems in the FMS, and we are achieving the flexibility in the systems. That is, we are achieving the competitiveness in the market and meeting the uncertainty of the market. What are the benefits of FMS? I think we have already done in previous classes also. Again, I such a little glimpse on this. So what can be the advantages of the FMS? We can see we can reduce the manufacturing cost, we can reduce the manufacturing lead time, we can provide the variety of products to the customer, we can increase the efficiency of the machines, we can also decrease the material handling cost, that is transporting material from one end to other end, we can increase the production rate by installing the FMS, we can reduce the inventory in the parts, we can also reduce the lead time, we can also achieve the quality of the products and the reliability and durability of the systems. So these are some benefits of FMS. That is why industries are being switching over to installing FMS in their industry and to be competitive in the global market. But every system has some advantages as well as disadvantages. So like this, also FMS is also having some disadvantages that we have to buy a number of operations or that may be required, may not be required in the near future. Like if you are buying a machine for FMS system, let us say you are buying a CNC machines and it can perform 100 number of operations. But in the near future, you need not to have use use of let us say 50 operations. But that is in the coming 10 years, you are only using 50 operations out of these 100 operations. That is, we have to pay extra amount of these rest of the 50 operations for which you may not require these 50 operations in the next 10 years. So that is the initial investment in the case of the FMS is very high. So the shorter industries or the SMEs, the short to medium enterprises cannot afford to install FMS in their industry. Also require very large machine utilization and also require very large computer operated simulation and modeling softwares. It also requires a skilled worker so that it can handle the various types of layouts, various types of machines which have been installed in the industry, and they can control and rectify the problems if there may be any problem in the case of the software and as well as in the hardware of the industries. These are some disadvantages or the problems that may occur while installing or while encountering with the FMS system in your industry. So the main that how you can install or how you can implement FMS in your industry. The main foundation of FMS or a flexible manufacturing system is the group technology, which is termed as GT also. This is basically uh, management philosophy, or you can say the manufacturing philosophy that seeks to improve the productivity by grouping the parts that have some similar manufacturing attributes. Let us say your industry is producing uh, five number of products for a single month. Let us say these three products have the same manufacturing operations and two have some same of manufacturing operations. Now you can club these first three products into the same group and club the product 4 and product 5 in the different groups because they have the same manufacturing operations first, second, and third product, and fourth and fifth have the different kind of product. But they have similarity in their products, but they are different from first, second, and third. So in that case, you are grouping the same kind of product which have on which same kind of operations have been performed. So the grouping of those components of those products which have the same manufacturing attributes, which require same kind of manufacturing operation is called the GT, and that group is called part family. It is called part. That is, let us say first three parts have to be require three kinds of operations, and they have similarity in the operations. Let us say drilling, turning, and painting is the operation that is being required on first three parts. Whereas on fourth, and fifth part will require coaching, knurling, and the painting. So there is nothing common in between first, second, third, and fourth and fifth. So you have to club the parts according to the manufacturing operation that is being performed under first, second, third, and fourth and fifth. So first, second, and third will lie in the first family that is called first part family, and fourth and fifth parts will lie in the second family that is called the second part family. And we will club the machines according to the operations that may be required to perform on first, second, third, and for the fourth. That is, हम क्या करेंगे तो पहले हमारे तीन पार्ट्स हैं और जो हमारे फोर्थ और फिफ्थ पार्ट्स हैं इन दोनों के अकॉर्डिंग हम मशीन्स को क्लब कर लेंगे. हमने पहले पार्ट्स क्लब किए एज पर द मैन्युफैक्चरिंग ऑपरेशंस एंड वी विल क्लब द part fourth and fifth, and then we'll allocate the machines to them. So this is the allocation of machines or clubbing of machines as per the requirement of first, second, third part and fourth and fifth part. So in this way, then that grouping of machine is called the machine cell. I again repeat, the grouping of parts as per the similar kind of manufacturing is to be performed on the specimens that is first, second, third, and fourth and fifth. First, second, third group will become first part family, fourth and fifth will become the second part family. Whereas whenever the operations which are being required to perform on these operations, these specimens, then these machines which are being required to process that parts, first, second, third, and fourth and fifth are clubbed in the two groups. So the group which we required for the first, second, third part is called the machine cell 1, and the machines which are being required to perform the operations on part fourth and fifth are called the machine cell 2. This is how the group technology is being worked or this is the principle of the
फिर आवाज चली गई.
so you can see in the figure also by manually inspecting, or we have some techniques also to identify single manufacturing operations or single manufacturing attributes of the specimens. So you can see there are two rows we have, let us say 8 parts or 8 components here. So you can see this is the first, second, third, and fourth. So you can easily identify from your naked eye also. Up clear? Up clear was?
Yes, sir.
Hello?
Yes, sir.
Is it clear now?
Yes, sir.
Hello, was clear? See the first row as well as the second row. So this is the part. So this is the first part, and this is the last part of the second row. You can see they are the same kinds are being required for this part as well as for the this part also. And also you can see this part is looking similar as well as this part is looking similar for the same. So this is how we are grouping the components. Similarly, you can see this part, this fourth number, second number component, first number, and the third number. So they have the same kinds of design and manufacturing activities. So this clubbing of all the parts which are having the same manufacturing operation is called the part family. So this becomes first part family, and this becomes the second part family. And for performing the operations on the first part family will have a clubbing of let us say n number of machines. So that n number of machines will lie in the machine cell 1, and this for the club for performing the operation on the second part family we have the machine cell 2. So this is how GT computer technology works. So this is, you can see, if we can produce mass production, batch production, as well as a job shop production with the help of the group technology. As soon as you have to move, you want more production volume, that is, you require the production, the mass volume, then you cannot achieve the product variety. Whereas in the batch type production system, you can see you can achieve product variety as well as the production volume. Whereas the job shop, you are only concentrating on product variety, but you are not achieving any production volume with the help of the job shop production systems. So job shop is for heavy variety or the high variety, you have to switch over to the job shop. If you want molded variety with a moderate quantity, then you can opt for the mass production system. But if you are using a single type of product in your industry in the large quantity, then you can opt for the mass production system. This is the computer integrated manufacturing. You can see similarly as per that of the I have shown in the previous slide, as computer control and systems with the help of the in the flexible manufacturing system. So this is the concept. This is computer integrated manufacturing system. And you can see the CIM is controlling all the aspects or all the attributes, all the modules of the industry, that is, it is controlling the design of the product, it is controlling the process planning, production planning, it is controlling the purchasing, manufacturing, automated work center, it is also controlling the finance, information, and marketing and sales. Everything is being controlled by the computer system. That is why it is called the computer integrated manufacturing system. This integration is also allows the individual industry to exchange information and within the industry and within the external industry also. That is, anybody from within the industry can fetch the information at any point. If a worker is, if a supervisor is working in a welding shop, he can fetch the data in a welding shop. If a engineer is working in the R&D department, he can also fetch the same data in the R&D department, the same data. That is, the integration is helping the individual processes to exchange information with each other and initiate action at the common platform. Next is the material requirement planning. So this is a system which is being basically used in industry nowadays to calculate the material and the components that are being required to manufacture a particular component or the product. So it consists of basically three types of primary steps. First is the planning of the material, second is how the taking the inventory of the material, and last is the reporting or identifying the components in the hands. That is, how much is the raw material being available now at available at industry, how much is the inventory, and how we are planning to manufacture a product, or what is the plan to procure or purchase the raw material from the market. And this is called the market material requirement planning. And with this, we are getting the purchase orders and work orders are being easily administrated using this MRP. So identifying which additional ones are being needed and then scheduling the production or the purchase. So this MRP is helping. to planning the uh, purchasing of the raw material from the market and watching on what how much is the inventory or how much the stock is available in the industry, and reporting that raw material as well as the inventory or the processed parts which are available in the industry, and also administrating the how the various policies or the scheduling of the purchase orders as well as the work orders that are being required from the customer side. So it is monitoring the purchase orders or the work orders. The work order means that is how many components are to be produced in a single month or a stipulated time which a customer wants, and the purchase order are that is how much is the uh, requirement of the order that are being received from the customer side. So it is integrating in between the inventory, the raw material procurement, and reporting of all the data, and in between the purchase order and the work orders.